So it's a secret, so I won't tell you guys. So, hi, I'm Azeez Elegbede. I popularly known as Ace. Um, so for some reason, I didn't put so much effort in this slide. I diverted that effort into the previous slide, and for some reason, we had to skip through all of that. I wanted to show off my slide skill. So pardon me. So this is me when I was still a new taker, but now I'm an old taker, so I'm a different person now. So I'm a software engineer who is passionate about making a positive difference in the world. That's a lot, but I do my best. I love open source, like you already know. So today I'm going to talk about API drifts. How many of you here like build APIs? How many of you here build APIs? That's funny because build APIs. So how many of you here consume APIs? Okay, awesome. A lot of consumers, less producers. So today my talking point is going to be, is it me or the mic? Okay, so I'm going to introduce you guys to API drift, some of the causes of API drift, real world impact of API drift, and how a sync API can help you prevent your API from drifting, and also how events can also drift. I mean, a lot of people don't know this, but your event can also drift. Best practices for preventing your API from drifting, some key takeaways, and then some question and answers. What is happening? Okay, it's working. I have a cute voice. So, introduction to API drift. So, for the folks that raise their hands for consuming APIs, have you ever encountered a situation whereby the API you were using before, the request you were making before that was working, all of a sudden stopped working? And you're like, I didn't touch anything, but for some reason it's not working. The same data I'm sending that was working perfectly before, all of a sudden is broken. And most times this is caused by API drift, right? Most times your APIs have drifted and you don't really know when that happened. And the funny thing is, a lot of us, we have this habit of always bookmarking the API documentation. We have it like bookmarked somewhere. And we just go there and be like, what changed? Especially if you are familiar with Swagger. And I'm guilty of that. I just bookmark the Swagger file and just go back there anytime I need it and something is breaking. I just go, oh, what changed? Why is it breaking? Why is this user authentication not working all of a sudden? What changed? And then you see nothing changed, but your API is broken. And then the reason for this is because someone that is building the API, someone that is responsible for the API, has made a change that you are not aware of. And for some reason, the change is not reflecting in the API documentation. So I used to say, in a nutshell, API drift basically means when your API implementation and the API documentation does not correlate. So that is basically API drift in a nutshell. So like I said earlier, so to the producers, the person engineering your API, this is what they feel like after the implementation. But you that are consuming the API, this is what your drift looks like after the implementation. And you're wondering, what the hell? What happened? So, like I said earlier, API drift occurs when the actual implementation of APIs, especially if you're working with microservices or event-driven APIs, it also happens a lot in REST APIs, starts to diverge from the original design. So that is basically what API drift means. And you're like, but why? Why does it happen, right? I mean, if the backend guys, I mean, that's a war I don't even want to go into further than backend, so please, let's move on. So we're like, if the people implementing, okay, I have to stay. Okay, I'm a bit nervous, so walking helps. But why? Why does it happen? And the most important reason why this happens is because people want to iterate. Iteration happens really, really fast. You want to add new features. You want to change the data payload. Oh, this is working before, but you have to like enhance it. Okay, maybe before the API for authenticating a user used to be like a flat JSON data or a flat JSON schema, right? But all of a sudden, it is converted to a nested JSON format, right? But you didn't know anything happened, and all of a sudden you try to like authenticate the user, but it doesn't work, especially if it happens on a Friday, when it's supposed to be a weekend. And you're like, but I told you guys, don't deploy on Fridays. Wait till Monday. And your consumers or your customers are like panicking, especially if it's a payment thing. Oh, the card is not working. Oh, my card is stuck. Oh, and you're like, you're at the beach trying to like take your pina colada, and your engineering manager is like buzzing you, ping, ping, ping. So what's wrong? And you're like, oh, the backend guys again. So, why is it a problem? Like I said earlier, APIs evolve really, really fast. They evolve quickly, teams move fast, and documentations lag, right? Especially in cases where you don't have like a technical writing team responsible for documenting your APIs. You just want to implement a feature and just move on with it, right? And then you forget to update the API documentation. And this also leads to broken contracts. How many of you here use OpenAPI? Swagger? Oh, awesome. So you know how you use Swagger as a contract to, Swagger supports I love to call it OpenAPI because the spec, the YAML file you write is called OpenAPI spec. How it allows you to generate documentation, which is the Swagger UI you see. How the spec itself acts as a contract for your documentation and also like for mocking data. So if you use Postman collection, let me see your hand. Oh, I think I'm gonna see you later. You're like a really cool dude. So this leads to broken contract, failed integrations, poor developer experience, especially if you are rendering your API as a service. For instance, like Paystack. Imagine you're trying to like integrate with Paystack API, and all of a sudden it's not working. And one thing about developers is when they're trying new integrations, you see, the moment they go to that documentation and the first endpoint they tried did not work, they are done. Like they just believe your whole software, your whole architecture is shitty. They judge you. Oh, developers. They judge you and they move on, which leads to poor developer experience. So let's talk about the causes of API drifts. Like I said earlier, incomplete documentation, right? Okay, I want to like quickly change the payload of a data, right? Let me just, okay, I want to add a required field. Let's say all of a sudden username is required. But before username is not required, right? Okay, and then I updated it, but for some reason, I forgot to update the documentation. I'm sorry, my guy. I forgot to like update the documentation. And I'll be like, I will do it later. I will do it, no worry. And then you forget to do it. And then for some reason, your documentation lags, right? Manual spec updates. Now, so if you're working with OpenAPI, I'm using OpenAPI a lot because I see a lot of people here do more of REST APIs than event-driven APIs. So if you're using like your OpenAPI spec to generate code for your backend, for your service, people used to manually just update the spec. So this can also like lead to API drift. Lack of version control. Don't get me started on this one. People just like have one version and they just keep iterating over that single version without creating new version for every iteration. This can also lead to API drift. Insufficient testing. Even me personally, I hate to test. I'm like, if it works, it works. Inshallah and vibes, that's it. Right? But insufficient testing can also make your API drift. Right? Limited tools and skill issues. Me, I'm guilty of that. So, like I said earlier, writing codes can lead to API drift and also the cultural challenges. So a lot of us work with companies that don't have this culture of enforcing you to write your APIs the appropriate way. Some of us don't have the ethic of adapting the API governance model, right? And this can cause your API to drift really, really quickly. So unless some of the real-world impact of API drift, like I said earlier, developer experience issues, developers don't have time. They would rather be with their babe than, stare at this fucking bug all day. Higher support cost. So if you're offering API as a service, and if your API is drifting, always customers complaining, it's gonna cost more for you to support your customers. Business impact, so you already know if your API doesn't work, you don't have a business, right? So don't let your API drift. Async API to the rescue. So Async API is just like Open API, but for event-driven architectures. So Async API is what Open API does for HTTP requests, REST APIs. You know, Swagger, so I'm going to use the word Swagger because I think a lot of you know it as Swagger here. So it's just what Swagger does for REST API. It's basically what Async API does for event-driven APIs, asynchronous APIs. But we've been saying asynchronous APIs, but what is asynchronous API? So how many of you work with WebSockets? So when you work any protocol that allows you to send requests and get a response in real time is basically an asynchronous API. So WebSocket is an example of an asynchronous API. If you can send event and send data in real time without having to like constantly poll, just like HTTP, right? So you're making an asynchronous request. So, but asynchronous API is those kind of protocols like WebSocket, Kafka, MQTT, name it, right? So Async API does what OpenAPI does for REST API, does it for asynchronous APIs. So what is Async API? I mean, my colleague already went through what Async API is. Like I said, OpenAPI of asynchronous APIs. The purpose of Async API is to document your event-driven microservices. If you're doing Internet of Things, IoT, you get Async API for that. If you're doing streaming services, many of us watch Netflix and constantly streaming YouTube. Those are asynchronous APIs happening, buffers and stuff. You're not constantly sending a request to load every part of your YouTube video. This is happening in real time. You're getting data in real time. You're getting events in real time. Your chat application, you're sending messages in real time. Those are asynchronous requests. And actually, pretty much everything that is system-based and message-based. So, as I said earlier, Async API supports all kinds of event-driven asynchronous protocols, right? So, OpenAPI only works for HTTP. It doesn't work for any other kind of protocols, just HTTP, request, response, right? But Async API is different. It basically works for everything. Synchronous and asynchronous. It does what OpenAPI does, but more, right? You can use Async API to document your AMQP, Kafka, WebSockets, NATs, even HTTP, the same thing OpenAPI does. So it's like OpenAPI on steroid. So protocol information is important for implementation details, but it shouldn't be the blocker for defining your interface, right? So Async API is, like I always say, one file per application. So you should have a single Async API file for a single API. So don't have one Async API file for multiple API services. It doesn't work like that. One file per service. Like I said, so the Async API file consists of, if you've seen OpenAPI, you already know this kind of data file structures. So we have the Async API version, the info about your API, the servers you're using, the operations, the channels, and the components. I'm not going to go into this because she already did. So let's see how Async API helps prevent, what do you mean, 5 minutes? Oh, OK. How Async API prevents API drifts. If you want, how many of you know about design-first approach? We have code-first approach, which I think a lot of people do. They have like this thing they want to do. They just go and start writing code, right? We have code first, and then we have design first. Some people design their APIs first before actually coding. And this is actually really effective. Why would you start writing code? You have like these business logics and everything, and you just start writing code, and you're going back and forth with stakeholders, back and forth with the people that are going to implement your APIs, when you could actually just design your API first and see what it looks like, right? And this is what Async API gives you. It gives you a machine-readable contract something you can use to design your API, which we call spec first. Right? Write your API specification first. Which that is basically you designing your API first. So we have this contract, which we call the async API specification, which is just a YAML file or a JSON file that basically helps you define or write or structure how you want your API to work, how you want your API to behave. So this is an example of the info section of an async API spec. So I have the async API specification, which I'm using the version 3, which is the latest version. And I have the info section, which is me basically just defining the information about my API, what my API does, right? So I have the info section, I'm saying, oh, this API basically just manage user services, right? User management, I apply the description, this service. So just the information about my API. I add my contact. This could be your company's contact or the service you're running the contact, the license and stuff. And then using the async API can also be used as a single source of truth. Like I said earlier, design first is the best approach when it comes to building APIs, right? Because when you have this spec, this contract, because the same thing works with OpenAPI, when you write your OpenAPI spec first, you can do a lot of things. You can generate documentations directly from your spec. You don't need to have a technical writer to help you document your API. You don't need to write it yourself. You can basically just generate this documentation from your spec. Async API does that too, right? You can also test directly from, mind you, you've not even written a single line of code, but you already have a functional prototype of your API, right? So you can generate documentation, you can run tests just based on your spec, right? You can mock endpoint requests just from your spec. You can generate code just like my colleague already did, just from your spec. You didn't actually write a single line of code. Design first approach, which I already said, that's a really good way to prevent your API from drifting. Design your API first, write out your spec. So this is an example of me having, so if I go to Studio, like my colleague already shared, I have 1 billion tabs. Studio is one of the async API's tools, and Studio is an amazing tool. It basically helps you, design your API without using VS Code. It's online, it's available, it's open source, right? So this is my spec on Studio, as you can see. In real time, this is my spec, my contract, me designing my API. On the left, can you turn off the light? No. So this is my spec. Let me see. Is it bold enough? Okay, so this is my spec. This is me writing my async API specification. This is me designing my API, right? I provide the API information, what the API is about. I define the server I want to use for my API. In this case, I'm using WebSocket, right? It could be HTTP, you could be using Kafka, you could be using NAT, you could be using MQTT, you could be using any kind of protocol, any kind of server, right? In this case, I'm using WebSocket, and I'm specifying in my doc, in my spec, that I want to use the localhost. I mean, everyone knows what localhost is. And then I specify my channels and how my API should work. I'm basically just designing my API. And in real time, what you can see on the right-hand side is a real-time documentation generation of your spec, how your API is going to look. And you can basically just take this and give it to your stakeholders. Okay, this is what I want. This is my API. You didn't even write a single line of code. You didn't have to get a technical writer to document your API for you. You get everything out of the box, right? So this is me getting an HTML, visually appealing docs explaining what my API does, right? And you can see it says, oh, this is my API information. Okay, this API has servers, but it has only one server. So if you want to connect to my API, you just have to connect to this server, this one here. And it says also in the description, this is a development WebSocket server, which means this is only running locally. So you cannot, it is not deployed yet, right? And it says these are the operations you can execute on my API, right, you can receive from this particular endpoint, right? And it says these are the messages that this particular endpoint can receive. So if you're familiar with WebSockets, so you know how this works. And you can also send to this server, right? Just like you would do in a Swagger file, different endpoints, the same thing, right? So you can get all of these, you can deploy this and just give it to whoever that needs to like test it, right? Without writing a single line of code. So let's go back to the slides. So that's the beauty of design first. So let me do a quick demo. I don't like demos. They always tend to fail. Hopefully this works. So let me just quickly show you what we're going to be doing, what I'm doing, what is happening. So I'm going to drop this real quick. And I'm going to pull up VS Code. So I already cooked together a demo, which is basically just a collaborative drawing application, which means multiple people can draw on the same Canva at the same time, right? So I'm going to spin it up and then show you what it looks like. Okay, then I'm going to go to server. Okay, so I have my server and I have my client. I'm sorry, I'm so used to using a mouse. This looks really weird. Okay. So I'm going to change my directory to my server, and I'm going to run my server. And I'm going to show you, I'm going to do a walkthrough of the code, right, and how it works. So I'm going to spin up my client. I think start again. So this is what I'm doing, right? So I have this interesting application. I have to enter my username and then my color. I don't know if you can see it. Here it says enter username and enter pen color, right? So in order for me to draw on my canvas, I need to create a username and a pen color, right? So I'm going to create a username, Ace. And then I'm going to create a pen color, let's say blue, right? And then I'm going to enter. Okay, I need to go down a bit. Demos, really. I think the projector is sort of making it look weird.
It works on your machine.
Yeah, he always works on my machine. So this is like me drawing on my own canvas, right? So if I open a new browser and sign in a new user, right? So let's see what happens. Let me escape this for a while, and then go to localhost, and then enter a new user. Let's someone volunteer a name.
Lawrence.
Sorry?
Lawrence.
Lawrence. I don't know how to. Let me know if I'm correct. Enter what color? No, choose another one.
Pink.
Pink. Oh, okay. Okay, let's use red because red is very popular.
Lawrence and pink.
So Lawrence already logged in. You know we chose red for you, right? So if you draw on this Canva, you see black, right? But you chose red, of course, because this is your Canva. So by default, you're seeing black. But the thing is, the person on the other end will see red. So if I go back to your browser, and then I draw, and I go, oh, no, it's not working. Demo, Jesus. Okay, let me go back. I think because I have an instance already running. Oh, come on, don't fail me. Is it what? It's running, but I think it's not connecting. I hope it's not VPN. VPN sucks. Oh, come on. Do I have to do npm install? Oh. Okay, let's see if it's actually connect. It's not connecting. Oh, I know why. Sorry. I know why. So this is I was doing some last minute changes and I forgot to revert the ports for the server. So this is why it's not working. So I'm going to restart it. Wait, let me restart the server, bro. Okay, so it should work now. So let's do this again. Refresh this. I choose username Ace. I choose color red. I log in. It's working. Now you can see, like earlier on when I logged in, I didn't get this alert. So this alert is basically telling me I have successfully initiated a connection with my server, right? And it's showing me the number of connection, which is 1, since I'm the only one logged in. And then showing me the status. Status is 1, which means a successful connection. 0 means it's not successful, right? So I go back and sign in a new user. Where is the second tab? This one, okay. I refresh it. I choose, let's say Luis, and I choose the color. What did I choose before?
Red.
Okay, let's use green, right? Enter, and it says number of connections is now 2, and connection state is 1, right? So if I draw on my Canva, right? I mean, I'm saying black because this is my Canva, but if I go to the other user's Canva, which should be this one, you can see it's green, right? I can draw my own Canva too. I mean, I will say black, but when I go to the other, what the other person will be saying is another color, right? Red. So this is all happening in real time. And this is how instant messaging happens. How we, simultaneously text each other, and we all like saying, okay, blue means, it has like you've read it, those kind of things you see on a daily basis. They happen. You don't see the behind the scenes, but this is what happened. But the problem is, when you're working with this kind of APIs, I already said earlier, this is a client, right? Then there's a server running differently, right? So imagine I have this is my API, right? This is the documentation for my API. So if you want to connect to my server, all you have to do is go through my docs, right? Okay, if I want to connect to this server, so you have maybe, let's say this server is running, it has been deployed, it's not running on localhost, and you want to also connect, set up your own client and talk to my server, you definitely then want to go to my documentation and say, oh, okay, let's see how I connect. Okay, to connect, I have to find a way to connect to this WebSocket server. So I need to initiate a connection to this endpoint, to this host, right? And then I can do 2 things. I can receive, and I can also send. So which means I can send events, I can send messages, I can also receive messages, right? So it's saying, oh, if I want to send message, then it says, oh, what kind of message can I send? Then it's showing you this operation. So if you're receiving, you can receive this type of messages, right? So it's saying you can receive this kind of message. So if you open the message payload, it's going to show you, right? Which is what you saw earlier when we initiated a connection. We saw number of connections, and then that alert. That's what you see. The number of connections and number of status. So everything is documented, right? So let me show you something interesting. Let me show you something interesting. So if I go to my server, right? This is my server. So I'm using Fast API. How many of you use Fast API? I know, old school. So let me try to zoom in a bit. So this is my server. This is basically the server running behind the scene for this collaborative drawing application, right? So I have my server. But most people, when they are designing their APIs, right? For some reason, because writing API specification is really simple, right? So because you have a design, then you can have your implementation, you can write a server, and then based on your design, you just have to follow the design, right? But the problem with this is, if you manage your specification, if you manage your design separately from your implementation, you can easily drift apart. And the problem is when you, for instance, say, okay, I want to add a new message payload, or I want to like extend something. Maybe by before I only have name and age in my payload, right? And you're like, okay, I just want to like include just one more property, right? Which is, let's say, gender, right? And you're like, okay, I have the logic already implemented in the code. I will just update the spec, right? I will just update the design. But the thing is, what if you forget? But you already have your API, your server deployed. And then this guy that is already trying to like consume my API, for some reason is saying, oh, but this thing only requires 2 fields, name and age. But then this guy already included gender or something, but it is not updated in the documentation, right? And that's why I always push that your spec, your design should be part of your implementation. Let it go hand in hand. It's really not difficult. And the interesting thing is, when you implement your spec, your API design, alongside with your implementation, you can never drift away. Because if your spec or your design is part of your implementation, if you, for some reason, try to include a new additional property in your payload, right, and you try to deploy it, your server would not even run. It will tell you, oh, something, no. Your contract says just 2 payload, but your implementation is requesting 3 payloads. Where is the third one coming from? Right? So can you imagine how your API cannot drift apart? So this is an implement. So in this server I've written, right, I can easily just write my normal WebSocket server and then maintain my contract separately. But the thing is, if you bring your contract and your implementation together, you have a really, really solid and reliable API, right? So let me show you an example. So I'm using Async API spec. So if I don't want to go into like, so I have this parser, and my colleague already mentioned parser earlier. So I'm using the Async API parser to parse my Async API spec. The thing is, the parser understands the spec. So the parser knows everything about the spec. So what you just have to do is pass your Async API file to the parser, and then the parser handles everything, right? From the parser, you can get the channels, you can get your API information, you can get the servers, you can get all sorts of things, which basically it is compliant with your environment, right? So I'm using the parser, and then it says from file because I'm reading the Async API from file. This is the Async API document here in my file, in my server, right? And then I'm just using the parser in my server to read the Async API file. Again, you get the document, and how this function called validates payload. This is interesting. So what this function basically does is, anytime a request is sent to my server, I want to validate if that payload is correct or not. So let's make a quick change. Let's do something interesting. So if I come to this, so if I go to my Async API file, so let's update something interesting. See something. So let's go to chat. So because I have a chat functionality in the, so you can draw in real time, you can also send messages in real time. So if I come here to this one, if I send a message, if I say hello, so if I go to the other person will get the message. So if I come here, oh my days, I have so many tabs, I'm lost.
I think picked it from the bottom.
Bottom, right? Okay. Okay, let me see. I have 2 tabs. I can just.
Yeah.
Ace, come on. Let me just open a new one, so since I can't find it. So let's use Delay and blue, right? It says 3. I don't know where it is. So if I send hello, right, or wow, and I go to the other browser, wait, now I can't find that one. So let me say hello there, and then I come here. Oh, you should work. Okay, I know why it's not working, because I already tested it. So let me show you something. Now I can find out VS Code. Okay, so see something. So I sent a message, right, in the message payload, and for some reason the message did not work. Why? Because when I go back and check my schema, right, the payload for sending a message in my contract, this is what it says. These are the properties I can send, right? I can send a type, I can send a text, I can send a timestamp, and it's saying all of these properties are required. So if you want to send a message to this chat endpoint, you need to send these properties. They are required, which is interesting, right? But look at something interesting. I'm also saying in this payload, no additional property can be added.
Even optional.
You cannot, I'm specifying it in my contract. No additional properties is allowed, right? But what I'm doing is in my client, I'm sending an additional data. So if I open up my client for you all, so this is my client. It's just a simple React code. And I go to where I send message. So this is where I'm sending the message. Let's see, to the chat component. And I'm sending the message. So this is my message I'm sending for my client, right? I'm sending the type. So let me show you the required properties again. If I go to Studio, I shouldn't have done this while I'm coming here. So if I go to my Studio, right, and go to the chat message payload, the messages I can send, join. So this is the chat message, right? It says type is required and it has to be a string, right? Text is required, it has to be a string. Timestamp, the time I'm sending the message, is required also, it's a string. But it's not just any string, it's a format of date, time, right? And then it says additional properties, never, right? But in my client, I'm adding an additional property. In my client, look what I'm doing. I'm so stupid. I added an additional property of incoming false. So this would not pass. My server would throw an error, would tell you, hey man, this is not allowed, right? And this is possible because of the async API parser and the async API validator that I'm using. And I'm doing all of this because I want my implementation, my server, to use the contract as a single source of truth. The contract is the only thing that both the server or the client has to respect. So I'm adding an additional property when the spec is telling me no, no, no. No additional property is required for this chat message. Right? So this enforcement is some of the reasons or one of the important things you can do to actually make your API implementation really, really strict to avoid it from drifting. And it's crazy when you're especially working with event-driven APIs like WebSocket, because the little things can actually go unnoticed. Especially maybe you're using like Kafka. I don't know how many of you guys have worked with Kafka when you're constantly streaming events, right? Your event might fail because in this case you have a producer and you have a consumer that are working in real time. And the interesting thing about event-driven systems is that the consumer and the producer, they are not aware of each other. Unlike an HTTP request where when you send a request, you wait and you get a response. But in this case, in the synchronous APIs, you don't wait for a response. You send a request and you move on. So when a response is available, it gets sent to you. Right? So in this case, anything can fail. Because you're sending a request, you don't even know if the request is valid or not. Your consumer just takes it. Because the producer is unaware of the consumers. They don't know each other. They can be deployed in different instances. They can be used in different ways. And that's the beauty of event-driven architectures, right? You manage them independent of each other. So I have run out of time. I have I have a lot of cool stuff I would love to show you guys. But I have just 5 minutes left, so I'm going to move on my slide. Hopefully it works. So, like I said earlier, your events can drift too, right? It's not just the request, it's just not your event, the schema, your data payload like I showed you earlier, they can also drift, so you can actually avoid that by using the async API specification. Preventing API drift in practice, I already showed you some, like the async API Studio, like I showed you earlier. You can use it to design your API and see it in real time, right? And see what you are doing, what you're designing. Spectra for linting, I wanted to show you this demo. This is actually interesting. So it's a way to actually link your payload to see if it actually conforms to your spec, right? Well, GitHub Actions, oh my, so if you can come meet me tomorrow, I have a big screen. I'm going to be demoing real-time simulations of this. So you can come to the async API booths if you want to have an experience of how it works. I would so love to do some demos for you. So we have GitHub Actions to validate your specs. A lot of us do a lot of CI/CD, continuous integration and continuous deployment. So your async API spec or your API spec can also be a part of these implementations, right? You deploying your code, you write integration tests for your code, your spec can also be a part of this, right? Code generation, my colleague already talked about code generation, how you can just write a spec and generate code without hassle, right? You don't have to write code. We have a little boilerplate template, Node.js, Java. You get this code out of the box, and all you just have to do is implement your business logic, right? That's what you're just doing, just a business logic. You're not worried about maybe the code. It would work, but I wouldn't advise you using production. So, schema registries, right? You can use schema registries too. We have a lot of schema registries. So we have a lot of schemas, JSON schema, Havro schemas. You can store your schemas in different places. You can version your schemas. These are things that can help you prevent your API from drifting. So async API integrates in a lot of any tool that is available that does event that simulates or handles events supports async API. We are an industry standard. So we have companies like Lego, IBM, Slack, mention it. They use async API behind the scene. Best practices, as I said earlier, treat your spec as code. Your spec is always treat it as your code. Store it in Git, review it in pull request. Your spec is a single source of truth. Automate your specs in your CI/CD pipelines, like I said. Share generated docs with your team ASAP. Immediately you have it, share it. Don't wait. Share it. I mean, if you have it implemented in your CI/CD pipeline, you don't even have to worry about that because it is done automatically. Version your spec clearly. I mean, that is always important. And always update your spec first, like I said. Whatever change you want to make in your API implementation, make sure it has been written, it has been designed in your spec before doing it on your code. My key takeaway, you can't prevent API drift by accident. It has to be part of your development culture, right? As I said, a lot of these companies that their API drifts, they lack API governance, right? It's not part of their culture. So you can actually make this part of your culture by taking these best practices to prevent your APIs from drifting, especially if you have a very big API, especially in large scale. So that's the end of my talk. I wish I could show you guys. I have really cool stuff I want to demo, but you can find me tomorrow. I'll be at the booth, the API spec booth. I'm going to introduce you all to event-driven APIs, architectures, show you some real-life scenarios, and then get to have fun with these amazing people. Thank you very much, Azeez, and I'd like to see you all.